Hello and welcome to the first of 3 challenges for the SCADA and Industrial Controllers class on the National University of Colombia. We, the team, Yeison Hernandez, Sebastian Hernandez, and who's speaking, Elizabeth López, are meant to design a logic for the operation of the buffer station scene in Factory IO. For this challenge, we must program the logic on the PLC using ladder language, all of this simulated. Try this by means of a digital twin and OPC connections. The first step in our design is to develop a state diagram, in which way the first move is to develop a start and stop buttons that will start and stop the simulation. Likewise, we develop that there are 3 inputs and 3 outputs. The 3 inputs are the first sensor that receives the box, the second sensor that is right before the blade, and the third sensor that is just at the end of the second conveyor belt. The first output will be the first conveyor belt, the second conveyor belt, the second output, and the last one will be the blade that stops the boxes. With this, we develop the ladder logic.
So, having talked about the state diagram, let's talk about the ladder program. Here is some. In the ladder program, the first, second, and 5 rung, we have the stop contact. The stop contact is connected to the stop red button in the simulation that helps us to stop all the actuators whenever this button is pushed. In the first rung, also we have the start button, the green start button in the simulation that was to initiate the first band. The first band then is locked whenever the start button is pushed. And then we have some logic to help play with the blade and the band 1. Whenever the blade is up, the band 1 will stop so that the crate does not collide with the blade. And when the blade is down, the sensor 2 and timer.tt contacts help us to get the band moving again, so the crates pass to the second band. In the second rung, it's normal locked within the band. Whenever the sensor 2 is activated, it's important to clear that the sensor 2, that is the at entry sensor in the simulation, have the logic inversed. So the sensor 2 is activated whenever the box is not there. Okay, that is the reason that we have the sensor 2 with normal close contacts. In the third and fourth rung, we have the timer and the counter. The timer is connected to the sensor 2, and whenever the crate gets to the second sensor, it will wait just a second, a little bit less than a second. That is the time that takes the crate to get to the initial of the blade, that is measured empirically. And in the fourth rung, the counter is connected to the sensor 1. So this helps us count at least that 2 crates gets to the sensor 1, and then if at least 2 crates get there, the blade will activate it. Yes, this is condensed in the 5 rung, that is the simple logic to activate the blade. Whenever the counter is ready and the timer.tt contact is activated, that means whenever the second pass, we have activated the blade, and that's all the program. We're gonna the logic that we will download into the PLC to this scene in Factory IO. It's called the buffer station. Still right? In this, we have simulated all the industrial environment, machine and pieces that we will just talk in the program explanation. And all of it works through OPC communication. The OPC servers that helps to build this communication is provided us throughout RS-Link, the classic launch control panel. Is create the OPC server that's connected to the Logix emulate program. That is the program that emulates the PLC that we download our program, and connected to the inputs and outputs in factory I/O. We will show in the demo in the next slide.
The first thing to do is to download the logic to the PLC. This will be done in module number 2. However, it will not always be like this. It depends on the initial configuration that you have on the logics. After the download, there will appear a pop-up window in which it is possible to change the offline to remote run. It is necessary to click yes. After all that, we can proceed to factory I/O. Now, we proceed to enable the OPC communication, clicking drivers and selecting OPC data access. After that, we proceed to match sensors and actuators with the signals coming from Studio 5000. Once we have the configuration of inputs and outputs on the PLC and the digital twin, we proceed to the simulation. We can run the simulation by clicking the green or on button, which will start the first conveyor belt. At this moment, the boxes will start to move. When the first box arrives to the second sensor, the blade will go up and the conveyor belt will stop. From now on, the boxes will pass one by one to the second conveyor belt that will be active when the blade goes down. Finally, to stop the process, it is necessary to click the red button, which is configured as a normally closed contact on factory I/O, but in the Studio 5000 logic it is posed as a normally open contact. Regarding recommendations, it is very important to ensure that the OPC communication is fully functional. If any step of the configuration is omitted, it will cause problems and the simulation will not run. In the same way, if the modules of the PLC are not correctly assembled and configured at Studio 5000, there will be problems with the execution of the logic and the development of the simulation at the digital twin.
Thank you for your attention. For more information, you can always access to our mails that are in the box below, and a special thanks to the professor of this class, Professor Eduardo Barrera.